Hi, everybody. These are your practice problems for compositions of transformations. So you've seen a lot of these types of problems in the previous video where I did some notes and examples for you, but I wanted you to have a chance to get a little bit more practice. So let's try these out. Okay. For a lot of these, I'm going to do one or two, and then I'm going to have you pause the video, try the others on your own, and then come back and check them with me. All right. So let's jump into it here. Okay, so this first one says interpret these composition of transformations. So what that means is take the math language and translate it into plain regular English. Okay. Remember, our rule when we're dealing with compositions of transformations is we always read from the inside out, or you can think of it as reading from right to left. Okay. So always the transformation that's closest to the figure comes first, and then the one that's further out comes second. Okay, so if I was to interpret this one, I would say that you always want to start with what's being transformed, which is this triangle. So triangle ABC, okay, is, and then you want to say what's actually happening. So lowercase r is reflection, so is reflected over the line, and then the subscript is the line of reflection. So this is the line y equals x. Okay, so that's what happened first. Then triangle ABC is rotated. So that capital R is rotated. Then put the degrees next. So 180 degrees around, and then the letter here, or it may be a coordinate point right here, is the point that you're rotating around. It's your center of rotation. So this is 180 degrees around the origin. Okay, that capital O that you see right here, that means origin. Okay. All right, so I'm gonna have you all try this one here and this one here. What you'll notice is that this second one is exactly the same as the first one, except flipped. Okay, and then this third one's a little bit different. Okay, so try these out, pause the video, try these out, and then come back and check your answers with me. All right, folks, welcome back. So check your answers here against mine. You'll notice that I worded this second one a little bit differently just to show you a different way that you could phrase these interpretations, right? But like I said in the example and notes video, it's more important that you're interpreting the vector notation correctly and you're writing that correctly rather than getting like having it be exactly grammatically correct or things like that. So for this one, we're still taking triangle ABC. We're rotating it first 180 degrees around the origin, then reflecting it over the line y equals x. Okay. And then in this third one down here, we have a reflection first and then a translation. So triangle ABC is reflected over the line y equals 3. Then triangle ABC is translated 2 units to the left. Okay, notice you have a negative 2 here for x, right? So that's 2 units to the left, and then 4 units up. So you have a positive value for y, so you're moving up, all right? So next, I think what's coming next is we're going to actually take some interpretations and write the vector notation with them. Give me a sec to clear my screen off, and then we'll look at the next set of problems. All right, y'all, here we go. So in this second one right here, we are going to take this interpretation or the plain English that we see here, okay, and then we're going to write the actual write the vector notation for it. Now, one thing I will say about these is that there's no figure that's being transformed, right? Like it doesn't say like these up here, like triangle ABC or point P or line segment XY, right? But rather our answers are going to look a little bit more like this. They just won't have an actual figure, right? It's just we're describing the actual transformation that's occurring to any figure, not necessarily just that one. Okay, so let's see if we can write these. So this translation comes first, okay? And then notice they're saying it's a translation of directed line segment. That's very similar to array. It's just like the path that the transformation follows, that the translation follows, okay? It's like these. Right? It's basically like the subscript of a translation vector notation there. Okay, so whenever you see directed line segment, don't be freaked out by that terminology. That's what it means. Okay, it's just how far you're moving left, right, up, or down. Okay, so we have a translation that came first and then a reflection. Okay, so that means if I'm working from the inside out, I'm going to start with my translation kind of more on the right, and it says I'm going from the origin to the point 0, -3. So that if we look down here at this coordinate grid, essentially your directed line segment starts at the origin and goes down to the point 0, -3, like that. So that's how far you're moving, right? And in what direction. Okay, so this is a translation of 0, -3, where we're not moving left or right at all. So 0 for x, and then we're moving down 3 units. Okay, so that comes first. Oops, lost control of my mouse there for a second. Really not doing I'm really struggling with my mouse today, y'all. Okay, so that comes first, and then after that, we have a reflection. Remember, reflection is lowercase r, and then you put the line of reflection in the subscript. Now, there's one thing that I want to point out to you all, is that sometimes you see these the translations written and the subscript of translations written with coordinate points, and other times you'll see them written like this. Okay, okay, either is fine, right? Like you can write them either way. It's just some textbooks like to use these little carets, and others like to use parentheses, but it means the exact same thing. Okay, so pause the video. I would like for you to try part B. So pause the video and then come check back with me. All right, y'all. So here is your written out vector notation for part B. So it says we started with a reflection about the line y = 1. So there's my reflection. And then it said followed by a rotation of -90 degrees. Remember, -90 means I'm going clockwise. Okay, not necessarily relevant for this particular problem, but we'll get to other problems where you have to remember that negative is clockwise when you're rotating and positive is counterclockwise. Okay, so I have a rotation around the origin, -90 degrees. Now, notice on this one, I used the little of notation, that small little circle, right? Either one of these is fine. You just have to use the one that makes the most sense to you. Okay. All right. So let's look at 3 here. Okay. Where I have this lovely arrow. Okay. And they gave me a couple coordinate points to pay attention to. So I have like the middle of my base at the point 1, 1, and then the tip of my arrow at 1, 5. So what we're going to do is perform these 2 transformations, okay, on this arrow, and see where, like, what coordinate point the tip ends at, what coordinate point the base ends at, as well as write a description. So similar to these, the interpretations that we wrote for number 1. Okay, so I'm going to do the first one, and then I'm going to have you try out the second one. Okay, so we're starting here with a rotation. Okay, and notice that we're not rotating around the origin, we're rotating around the point 1, 0. Okay, which is this point here. Nope, sorry, I put that in the wrong spot. Okay, is this point right here. Okay, and notice that I'm rotating positive 90. Okay, so positive 90 is counterclockwise. Okay, so I'm going to actually draw that on here so you can see it. So I'm going to take this whole thing and I'm going to swing it 90 degrees this way, which means this point in black, the one that originally was at 1, 1, is going to end up here. Okay, and then the point of my tip here was 4 units above it. 1, 2, 3, 4 units above the base, the point on the base. So I'm going to count 4 spaces to the left here because I took this and I swung it downwards, almost like the hand of a clock going backwards. Okay, so that point is right here, and then I can kind of draw that in. Not very well because Miss Engel is not an artiste. Okay, so that's the first part. Okay, that's the first part. And then next, right, second, we have to take this shape and reflect it over the line x equals 0. Remember, whenever you see x equals a number, that is a vertical line. Okay, and x equals 0 is the same as the y-axis. So that's this line right here. Okay, so I'm going to take this green arrow and flip it over the y-axis. So this point here, the one on the base, is going to stay the same, but this point here at the tip is going to move all the way over here, right? Notice that I'm keeping the distance the same between the original and the new point. Okay, so my final arrow would look, ooh, terribly drawn by me. Okay, but my final arrow would look something like this. So the tip of my arrow is at the point 4, 0. Okay, and the base is at the origin, the point 0, 0. Okay, and then if I was to write a description of this, right, or an interpretation, I'm going to write it underneath because I'm running out of space. It would be rotate the arrow 90 degrees counterclockwise around the point 1, 0, then reflect it over you could either say the line x equals 0 or you could say the y-axis. Okay. All right. So I would like for you to try part B here. Okay. Notice that these are both rotations, but because you're rotating around different coordinate points, then the arrow is going to end up in slightly different places maybe than you expect. All right. So give me a sec. I'm going to draw it out as well. Pause this, try it out, and then check back with me in just a sec to see how you did. All right, folks. So I'm gonna have to do a little bit of like scrolling while I explain this because the arrow, as you can see, kind of ended up way over here. Okay, so here we're doing first a counterclockwise rotation, 90 degrees around the point 1, 3. So I put the point 1, 3, marked it in green here. I took my arrow and I rotated it 90 degrees counterclockwise to get this green arrow. Now, if you struggled with exactly where these points would go, you kind of want to look at the relationship between the middle point and and where these endpoints are. So like this middle point that we're rotating around is 2 units away from both the tip of the arrow and the base of the arrow. So I would want that to stay the same even after I rotated it, right? Except now, instead of that distance being vertical, that distance is horizontal. Okay, then, so after we rotated it 90 degrees counterclockwise, we needed to then rotate it negative 90 degrees, so 90 degrees clockwise around a different point, the point 3, 3, which is this point here. So essentially, we took this whole green arrow and swung it all the way up around this point here. Okay, so rather than going back where it was, it's moved because we're swinging around a different coordinate point. Okay, so my base is at the point 3, 3, and then I know my distance still between the base and the tip has to be 4. So 3 plus 4 is 7. I kind of had to extend my axis here, okay, to get the tip being at 3, 7. Okay, and then there's my description, okay? All right, so then really quickly for these last few, this is a set of compositions, and we want to figure out how could we do this in one transformation rather than using two, okay? So with these, you kind of just have to map it out and see what happens, right? You can pick any point, any shape, and just kind of map out what's going on, okay? So here I have two translations. Notice that in this first translation, I'm moving one space to the, I'm moving one space to the left and 8 spaces up, okay? And then in this second one, I'm moving one space to the right and then 6 spaces down, okay? So this is essentially what you do with these is you take your X values and add them and do the same thing to your Y values. So really, I could accomplish this in one move by saying, well, this positive one and this negative one are going to cancel each other out, right? So I'm actually not going to move for X at all, right? So I can do a translation where I don't move at all for X, but if I go 8 spaces up and then 6 spaces down, really, I've only gone 2 spaces up. So I could do this double translation in one move by just moving the figure, whatever it is, 2 units up, okay? For part B, you kind of saw an example of this in the previous video, but let's say I have a shape that looks like this. I reflect it over the line y equals 0, which is the x-axis. So I take it and I flip it this way, and then I flip it again over the line x equals 0, which is the y-axis, right? So it ends up looking something like that. Well, I could have done that in just one rotation, right? I could have taken this and rotated it 180 degrees instead. So that would be my answer here, that I would rotate it 180 degrees around the origin. Okay. And remember that this O right here is not the number 0, it's the point, the origin. Okay. All right, then for this last one, I'm doing 2 rotations around the same point. Okay, so essentially I'm just taking a rotation and I'm breaking it up, okay, into 2 smaller rotations. So the point 2, 0 would be right here, okay? So let's say we had just another triangle shape, okay? If I rotate it 180 degrees first, it's going to end up, I'm kind of swooping around. It's going to end up down here, okay? And then if I rotate it again another 90 degrees, it's going to end up right here, okay? So rather than going all the way around, I could have just gone 90 degrees in the other direction, okay? So I could have done this as a rotation still around the point 2, 0, but instead of rotating 90 degrees, then 180 degrees, instead I'm going to rotate 90 degrees in the other direction. So that's negative 90 degrees. All right, y'all. So that is it for your practice problems for compositions of transformations and the end of the videos for section 2. So I'll see you all in the next one. Bye, y'all.